Today we are starting with chapter 9.1, which is limits. I would say this is probably one of the more difficult concepts this semester. So limits seems to be a very abstract idea for students. So I'm going to try to record it and then I will post it on D2L. So if you want to review, you can look at that again. I try to approach it in different way. Hopefully that would help you to understand what limit means. If we are doing it like a picture, so what they are doing here is they started with a circle with 3-sided graph and then 4-sided graph, and they increase the number of sides of the graph inside. So as the number of sides increase, can you see the inside graph is getting closer and closer to the circle, but it will never reach to the circle. That's kind of the limit. Like they get very close to it, but they never really match exactly. So this is like a geometric type of example. We say as the number of sides of this inside graph, which is a polygon, increase from 3, 4, 5, etc. As the number of those sides increase, then the polygraph will get closer and closer to the circle. They can describe this as this. This is the notation. We can say the limit as n is the number of sides for the polygons increase, then the limit is going to get very close to the circle. So this is the notation, and if I write that in words, we can say the limit of the n-sided polygon this is as the n number heading toward infinitive, the limit is going to be the circle, which means it gets closer and closer to the circle, but not exactly the circle. So if you still have a hard time, I'm going to describe it one more time on the side with different wording. So this means as n approach to infinitive, the n-sided polygon gets closer and closer to the circle. So this is the concept of limit. So that's picture, and a lot of your question on business math is not about picture. So we're going to give you some example using numbers. So the next one, we are going to try to plug in number for this term. So this is the term, and then we're going to plug in 1, 2, 3, and 4. So if I plug in 1 to this fraction, what do we get? So it's basically 1 on top and then 1 plus 1, right? So this will give me 1/2. If n equal to 2, so 2 on top here and 2 at the bottom here, so the fraction will be what? 2/3. And then the next one I need to plug in 3, right? So this will give me what? 3/4. And then plug in 4 in the n position, we're going to get 4/5. So what is happening with those fractions? Say if it's 1/2, that's like half of it, right? And then when you have 2/3, you cut in 3 equal parts, you have 2 of them, right? And then when you have 3/4, so this is 1/2, this is 2/3, 3/4, so I need 4 parts. And then you have 3 out of that, right? So it's getting bigger and bigger and closer to what? As the n get bigger. Can you tell? If it's like we plug in 99, what will happen at the denominator? 100, because it's 1 apart, right? If I plug in 999, then your denominator would add 1, which is, so 999, the bottom would be 1,000. Okay, something like that. So can you imagine this have like 1,000 little pieces with the same square, and then 999 of them will be filled out. So it's getting very close to the whole thing, right? So as the n get bigger, as n heading toward infinitive, the answer will get closer and closer to what value? Anybody know? This is very close to what? 1. But you also need to notice, but never which one, right? So we can describe this relationship as limit as the n getting towards infinitive for this particular fraction, and over n plus 1 is going to be very close to 1. The y value will be getting very close to 1. I think this is a very difficult concept for students. I'm going to write that in Word. The limit of this fraction, n divided by n plus 1, as n approaching to infinity is 1. Which means you plug in the n, your y value is going to get very, very close to 1, but not 1. Okay, let's do one more before we head to the question you probably will see on the homework and the test. So one more sequence. This time we just do 1 over n. So we started with n equal to 1, go toward infinitive. So if we plug in n is 1 for the first fraction, what do we get? 1 over 1. Second one, which is 1, right? Second fraction would be, okay, be careful, 1 is on top, bottom is 2. Yeah, 1/2. And then the third one would be 1/3. And the next one would be 1/4. So just like that, right? So if I plug in 10 for n, then we will have 1 over 10. If I plug in 100 for n, 1 over 100. If I plug in 1,000, 1 over 1,000. So as you kind of imagine how the graph look like, this is like one square and the whole thing is filled out. This is one square cut into 2 equal parts. 1 out of 2 parts is filled out. This one would be 1,000 little pieces, but still the same square. And then only like one little part is colored in, right? So this is getting very close to what? It's getting smaller and smaller, reaching to what? Think about it. So as n heading to infinitive, the answer or the limit will get closer and closer to what value? Last time is 1, this time we get closer to 0. Very good. Again, but it will never reach to 0. Okay, so we can describe this relationship as limit as the n approaching infinitive for this fraction 1 over n, that is going to be equal to 0, meaning the y value is getting closer to 0. So to describe this in words, this would be the limit of 1 over n as n approaching infinity is 0. So just want to introduce this to you because the limit is always very difficult for students to visualize what's going on. Okay, so after the introduction, we're going to start with the next page. So that's how your book introduces it. For the notation for the next page, they say limit as x approaching to a, f of x equal to b. So that's so many letters, so that seems to get students quite confused sometimes. That's why we show you the last part first. They say the function is f, which is the f of x, right, has the limit b as x approaching to a. So when x is getting closer and closer to a, then your y value will get closer and closer to b. So that's the normal notation. So we have 3 things we want to introduce to you. When we are trying to find the limit, later on you will see sometimes they are going from the left. So this is called like one-sided limit. So if you have like a little negative sign on top of here, because negative, when you see the number line, the negative will be on the left-hand side, right? So this is coming from the left. If you see a negative there for the one-sided limit, so this is not showing clear here. So for the one-sided limit, you can go from the left, and then you can also go from the right-hand side. Right-hand side is the positive sign. Some of the question will only ask you to find the one-sided limit, but if they don't specify this is on the left or on the right-hand side, that just means from both sides. So we will have these three different scenarios. So the three scenarios say, as x approaching a, f of x equal to b, only if the y value equal to b when x approach from both left and right hand side equal to b. So it's kind of like a lot of letter, right? So what they mean here is, if you have a graph, this is your x-axis, this is your y-axis. So we're looking at, say, b is here and a is here. We're looking for the limit, and then it hit this point. So they say the limit would be b if you're going from the left-hand side, approaching from the left and approaching to the right, they end up in the same point. Then you will have the limits equal to that number. That only happen when from the left and from the right like settle at the same point. Okay, so the second scenario say the limit does not exist. So this one has to be, the limit will equal to b when it's approaching from the left and from the right, both equal to the same number. Same number from left and right. Then you have a limit, okay? Number 2 and number 3, the limit does not exist. So when does the limit does not exist? And they will abbreviate to like D and E. So you don't have a limit, or the limit does not exist if they approach from the left and from the right end up with the two different values. So let me draw a picture. Hopefully that shows a little bit better. X and Y here, so you will have a graph. Maybe this is 1 and this is 2 and this is A here. So maybe from the left you will end here, and then from the right you will end here, like that. So when you approach from the left, your y value is 1. When you approach from the right hand side, your y value is 2. Because one is 1, one is 2, so they don't end up in the same number, then the limit does not exist. So they have to go from the left and the right, settle in the same number for the limit to exist. So this one say low limit if the graph approaching different y value from the left and from the right. That's basically what they mean. And the last one, also limit does not exist if they either one of them is heading to negative or positive infinity. I'm going to just give you one graph instead of multiple. So this is y again, this is x again. If a is here, you may have a graph like pointing up like this and pointing up like that. So the end will head to infinity for y, right? If the value is approaching to either negative infinity or positive infinity for y, then you don't have a limit. Limit does not exist. So the only time you have a limit is they have to approach from left and right and settle to the same number. Settle to two different numbers, limit does not exist. If they're heading the y value to infinitive, negative infinitive, limit does not exist. Okay, so this is just in general, and then we're going to move on to the one-sided limits. This limit is found when x just approaching from one side. It could be from the left-hand side with the negative here, or positive for the right-hand side. A function has a true limit so this is as x approaching to a if the limit which is the y value, is the same from the left and from the right. So far we keep repeating the same information. Hopefully it click with you eventually. We're going to use a picture to find some limits, and some of your homework question and exam question will be kind of like that. So we are using a picture, and then whatever they have here is your x value, right? Meaning you need to find the y value. If I have a negative sign here, it's approaching from what direction? So you should think about like this is the negative infinitive, this is the positive infinitive. So like the negative would be from the left, and the positive infinitive side, positive, would be from the right hand side. Okay? All right, so if the first one have a negative from the left, and then x number is x is -1 from the left, then the y value would be what? 1.5. Let me see. It's kind of set here, I think. So y will be positive, okay? And then let's look at from the right hand side. So from the right hand side, it's going to be this side, right? The y value would be, for x equal to -1, y would be from here, x equal to -1, y equal to 1. Okay, not trick question, okay? So this is x is -1, y is 1, right? This point. Because both from left from the right, we settle at the same y value. So in general, if they don't give you a direction, then the limit is going to be 1 because it's the same number, right? And if they just ask you to find this, which is the point, remember f of x is the same as what? Y. So if they give you f of -1, then the y would be what? 1. So this is just the point, okay? This means when x equal to -1, y would be 1, okay? I know it's like kind of weird, but that's something they want you to know. So the second one is x equal to +1. So have to be careful because when we see x equal to +1, it looks like this, right? From the left-hand side, reaching x equal to +1, what do we get? Y equal to 3. Can we see that? And then from the y-hand side is this, right? Y equal to still 3, right? Because both left and y equal to 3, so the limit would be 3. But then you have to be careful with the last part. The last part is separated. The last part say when x equal to 1, y equal to 1. It looks like 3, right? But it's an open circle, so does it has a point there? No. So I'm going to say f of 1 does not exist because it's an open circle. So this, again, this section, anything related to limit, I think is difficult. So I want you to review like each week. Otherwise, if you wait until the test, it's going to be very hard, okay? And try to do your homework also. Are we okay with number 3? Before we move on, any questions? Next one, we're using the same picture, I guess. I just didn't have enough room. Looking at the same picture on your paper and try to find, this is what direction again? From the left with the negative, and then the positive means from the right hand side, and the last one is from both sides, right? So looking at your picture when x equal to 2. So that one is trickier. X equal to 2 is here. From the left is this part, right? We will settle at y equal to 2. Can everybody see that? From the left, we settle at y equal to 2. Okay, so I'm going to write down y equal to 2 here. And then from the right-hand side, this doesn't have right-hand side here, right? So I need to use this part of the graph. From the right-hand side, go approaching x equal to 2. I will end up with y equal to, okay, from the right-hand side, x settle at 2, y is 5. 5. Okay, you may have to use like a ruler or the paper to guide you. Okay, so this point y is 5. Can we see that? Okay, so I'm going to write down 5 from the y hand side, right? If they don't have the same number, then does not exist, and we use that abbreviation D and E. Is that okay? How about the point f of 2? This means when x equal to 2, y equal to what? Let's look at the picture. When we have x equal to 2, does it have a point that you can use? The picture here have a solid point. This one have an open circle, so which point should we use? The solid point y equal to 2. So this equal to 2. Are we okay? So it's going to require some practice. So next they are actually finding the limits. There are several ways to find the limits, and they will follow these steps. So the first step is if you can plug in the x value, that will be the quickest way to find the limit. So the quickest way is anytime if you can plug in the x inside, then you will go ahead and do it. But sometimes it may not work. So if it doesn't work, you will move on to step 2. If it doesn't work, you have to try to see if you can simplify it, meaning you want to factor it and reduce it and then plug in the x. That would be the second thing to try. If that still doesn't work, then that's going to be a little bit longer. You will set up a table and check the value from the left and from the right to see if they settle on the same number. Okay, so we're going to try to do some of this, but what do I mean if it doesn't work? So for the first step, if it doesn't work, meaning that if you get a denominator equal to 0, maybe 5 over 0, that would means what? When you have a denominator equal to 0, that means what? Define. We cannot accept that answer, then we move on, factor and reduce, or set a table. Or the other scenario it will not work is if you have a negative under a square root. What do we have when we have a negative under square root? We will pull out the negative as I. This means imaginary number. So in these two scenarios, you cannot just plug in number. You have to do some more and figure it out. Or it could be a number over 0 or 0 over 0. Anyway, let's try the next question. So some of your test question will be like the next part. They give you a function to find the limits as it approaching to 2. So let's try to see if the first one, if we plug in there for the first one, what will happen? This one. Can I plug it in? If I plug it in, what do I get? I have something cubed minus 5 times something minus a 1, and I'm going to plug in what? 2. So make sure you follow the order of operation, exponents first before multiplication and stuff. So that will give me 2 times 2 times 2 is 2 times 2 times 2 is 8 minus a 10 minus a 1. Altogether we will have negative 3. And if you need to use a calculator, that's perfectly fine. So A is not too bad because we can just plug it in and be done with it. So the answer would be negative 3. How about the second one? If I plug in number, what would I get? I would have like a 2 squared minus 4 and then 2 minus 2, right? So this will end up with 4 minus 4 is 0, 2 minus 2 is 0, so that's not okay, right? So when that's not okay, the second things we should try is what? Instead of just plugging in, we're going to need to factor and reduce. X squared minus 4 is one type of factoring. What type of factoring is that? The top part can be broken down as, this is x squared minus a 2 squared is going to be
x plus 2, x minus.
Yeah, that's the difference of 2 squared, x plus 2, x minus 2. Like if you're not very good with factoring, please practice and review factoring or get tutoring because you're going to need that skills for the new material. At the bottom, we just have x minus 2, right? Which means I can reduce the
Get rid of the x minus 2.
The x minus 2 match exactly, right? So now we have the limit I should really write the limit as x approaching to 2, just x plus 2, right? So I can try to plug in number now. So this will give me 2 plus 2. So the answer should be 2 plus 2 is 4. So if you just plug it in and you get something that's not okay, which means here 0 as your denominator, you will factor and reduce. The top part is different of 2 squares. So again, if you need help with factoring, you need to try to get that like quickly this week and next week, okay? All right, how about the next one? Can I just plug it in? Let's see. What are we plugging in? -1, so it's 2 times -1 square plus 3. You put a -1 square, which will give me, okay, -1 times -1 is +1, so it's 2 times +1 plus the 3, which will give me, 2 plus 3 is going to be a 5, square root of 5, so that's done, right? So the easiest way, if that work out, is just plugging in number. The B, it didn't work out because I have a 0 denominator, so I have to factor and reduce and then plug in, okay? How about D? Can I just plug it in? Maybe. Let's see. So if I plug it in, what am I plugging in?
2 times 4 and 3 times 4 plus 1.
Good. So on top now we have 8 over
13.
12 plus 1 is 13, so it's just 8 over 13. Would that be okay? Yep, it's not 0 in the denominator. It doesn't have imaginary number. So the easiest one is just plug in number. But if it doesn't work, factor, reduce, and we haven't done the table stuff yet. Okay, question for this. That's the second type of question you will see on exam 1. All right? And sometimes they may come in like a piecewise function like this guy. If it's like a piecewise function, then we have to be careful what number they give us. So this one is less than 2, you use the top function. Greater than 2, you use the bottom function. So for A, what do I do? This is x approaching 2 from what direction? With the negative sign mean from the left. So if it's from the left, that would be less than 2 or greater than 2 from the left-hand side of the number line. Less than 2, so from the left, it means x is going to be less than 2. When it's less than 2, we're going to use the top function. So I need to plug it in, but I am using f of x equal to x squared plus 1 because my x value would be less than 2. So if I plug in f of 2 here, then I am going to have 2 squared plus 1, which will give me what? 2 squared is 4 plus 1 is 5. So that's the first one. And the second one is coming from the right-hand side. So from the right-hand side, all the number would be bigger than 2 or less than 2. Bigger, so this time would be x is greater than 2. Because it's greater than 2, looking at the piecewise function, I will use the bottom function. We're going to use f of x equal to x minus 1. Plug in 2 there, get me the answer in a minute. So the answer is just 1, right? So what is the limit as x approaching to 2 for this function? Does not exceed because one is 5, one is 1, right? So they have different number. So I'm going to say does not exceed. Not same number from both sides, right? But what is f of 2? Do we have that number? So this means when x equal to 2, y equal to what? Because this represents f of x is y, right? Do we have f of 2? No. Because like if you look at the questions, one is less than 2, one is greater than 2, right? It was never equal to, right? So because x does not equal to 2 from the questions, we are going to say f of 2 does not exist. It's because the original question doesn't have equal to. So you're going to have some homework question kind of like that. There's like a few with the piecewise functions. Any question for this? We're going to do the last page and review a little bit about polynomial and quadratic before you go.
The next part is indeterminate forms.
So I'm telling you, like, normally students have the first 15 days to switch schedule. So right now you're in this class. If you want to pass it, make sure you come to class, do the work, and make sure you get the homework, because homework is 15%. So I never have students like pass the class or do well without having any homework. So if you plan to stay in this class, you will have to get homework. And if you feel like this is not the right class and you want to switch to something else, make sure you do it quickly. It has to be by the 15 days. Otherwise, you're stuck in this class. So just want to let you know. Is the limit expression a 0 over 0? Found the limits and explain why it does not exist. So this is using the same rule we told you. If it's from both sides and they end up with the same number, you have the limit. If you have a 0 in the denominator, limit does not exist. If you are heading to infinitive, the limit does not exist. And when we try to find the limits, we always try to plug in the number first. If it doesn't work, then we try to factor and reduce. If it doesn't work, we reset the table. So one of these, we're going to need to do table. So let's try A. Let's see if we can just plug in the number. That would be the easiest way, right? So we can plug in x equal to 1. So 1 minus 1 on top. At the bottom, we have 1 raised to second power plus 1. What do I get from here? On top, we have 0. And 1 squared is just 1, right? Plus 1. So this would be
0, just be 0.
yeah, 0 over 2 would be just 0. Is that okay? Yeah. It's not undefined. This would be just plugging in would get us the answer. Okay, second one. Can I just plug it in? Let's see. So if I plug in, that would be 1 on top, minus 1, and then 1 squared at the bottom. So the top part, we're going to get what? 0. The bottom part, also 0. Is that okay? Not okay. If that's the case, we're going to need to factor and reduce, right? We're going to move on to the second strategy, which we factor and reduce. So we factor and reduce, like we start with limits as x approaching to 1. Okay, the top part I cannot factor, but the bottom part is different of 2 squared, which we factor to.
X minus 1, x plus 1.
Perfect. So again, if you are not quite sure about factoring, you have to practice it, okay? What can I reduce? X minus 1 is gone, so the top part we are going to end up with what? Okay, if I get rid of the whole thing, what do I put on top? It's not 0, but it's like you have, say, 5 divided by 10. This is 5 times. Okay, 5 times 1 is 5, and then 5 times 2 is 10, right? It's like that. So if you get rid of the whole thing, you put a 1 to hold the place, because it's this times 1. Okay, so that you get rid of the whole thing, we put what there? At the bottom, you have x plus 1. So let's see if we can just plug in number at this point. What are we plugging in? Just 1. So 1 plus 1, we have 1 half. So again, plug in. If it's not okay, factor and reduce it. So the last one, can we just plug in? Let's see. If we plug in, we have 1 plus 1, and then 1 squared minus 1, so it's 2, 1 minus 1, so it's 2 over 0, right? So that's not okay. Undefined. And if we try to factor and reduce, then we have limit as x approaching 1. The top part is just x plus 1. And the bottom part would be what? X plus 1, x minus 1, which we can reduce. X plus 1. So this will be. So 1 here, x minus 1. So you told me 1. This is 1 minus 1. So it's 1 over 0. So that's still undefined, right? So the first two steps didn't get us the answer. Then we have to do the very last step, which is set a table. So that is a little bit harder. Step 3, say we try to set the table. And what do they mean by that? So when you set the table, what you will do is you will try to see this is x supposed to be 1. And then we want to plug in some number on the left-hand side from the number line and some number from the right-hand side of the number line, but very, very close to 1. So if I say negative 0.99 is very close to 1, then something need to be even closer. What would that be? Negative point, I need to get more decimal places, negative point.
0.999.
Yeah, 3 places would be closer. Then I need a positive number, very close to 1, but a little bit bigger than 1. I can have just 2 decimal places, 1.01 here. And if something even closer would be 1 more decimal place, can be 1 point.
0, 0.
Yes. Okay. We have to work the number line a little bit. So what happened here is you are using the fraction they give you, and then plug in negative 0.99. So negative 0.99 plus the 1 over negative 0.99 square, the whole thing square, and then minus a 1. So you can put it in a calculator, because I know this is kind of a mess. If you plug in the calculator, you should get a negative 100 here. Okay, and then you do the same with the next number, plug into the calculator. This would give you a negative 1,000. On this side, same deal. So if I try to plug in 1 like this, it would be 1.01, and then add a 1 on top, and then 1.01 square, and then need to subtract a 1. If you put that in a calculator, you should get 100 on this side, and then 1,000 on this side. We want you to kind of imagine what's going on here. So is it heading to a certain number? This is a negative 1,000, this is a positive 1,000, but the number jumped pretty quickly, right? What do you think the trend is heading to what? On this side, it's going to approach to negative infinity. On this side, it's going to approach to what? Positive infinity. And because it's heading to infinitive, so the limit for this particular guy is going to be, so limit for x head to 1, x plus 1, x squared minus 1 is going to be, whenever you're heading to infinity, what happens? dne. Okay, does not exist. I know this is not that fun, but this is going to be the first exam, and a lot of students fail the first exam because of the limits in general. So this is hard, so you need to really study this. All right, so if you did the online lesson from Tuesday, we did 1 difference of quotients, so now they slap a limit in it. So we have to figure that out. This gives you a function which is 4x minus 5, and I was watching what the coordinator was doing. She even have a much harder one. They have a square here. So we just tried one that's more straightforward here first. And then we are going to see if limits as h approaching to 0, what will happen. What we will do is, first, we should figure out what is this part and what is this part, so we can plug it in. If we're just doing f of 3 plus h, so first we will find, and then f of 3. We're using this function. Whenever we see x, we plug in what? The first part, and when we see x, we plug in what? 3 plus h. So we have to be careful with that. Equal to 4 times 3 plus h. And then subtracting a 5. Okay, distribute in there, what do we get? 12 plus 4h minus 5, combine like term.
Yeah, 12 minus 5 is 37, sorry.
Okay, you're fine. Okay, 7 plus 4h. So this is the first part here, right? And then the second part would be f of 3, so we will plug in 3. So we are going to have 12 minus 5 is 7 for f of 3. So using this, we're going to put in the original question, right? We started with limits as h approaching 0. The first part is this guy, which is 7 plus 4h. And then we will minus f of 3. f of 3 is 7. At the bottom, we just have h, right? Okay, so this is limit as h approaching 0. What do we have on top? 7 minus 7 is gone, right? Just 4h. And then over h. Yeah, the h is gone, right? So this would be limit as h approaching 0 and a 4 here. Is there anything I can plug in here? Is there like a h that I can plug in? There's nothing I can plug in, right? So this is kind of strange. They say nothing to plug in. So the answer is just 4. Is it okay? I know it's a lot. Okay, so this is 9.1.